Hello everyone, my name is Justin Tessier, right here is Sheridan Moulton, and right here is Emily Pelletier. And today we're going to be talking about Leonhard Euler and a couple questions dealing with geometry and mathematics. Let's get started.
So today we're doing a grade 4 to 5 lesson and we're going to do 3D shapes. So first, can anyone tell me what this shape is?
It's a cube.
In fact, a cube. This is our first 3D shape that we're going to learn today. And we're going to learn what a vertex is, what an edge is, and what a face is. We're going to do a recap on our vertices, edges, and faces. So first, a vertex is the points where all the edges meet. Can anyone tell me how many vertices are on this cube?
8.
8? Okay, let's count together. 1, 2, 4, 5, 6, 7, 8. We have 8 vertices. Now we're going to do our edges. So our edges are what connect the vertices. I'm going to do this in blue. For example, this is an edge. Can anyone tell me how many edges we have here?
10.
10. Let's count them together. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now that we counted together, we know that there are 12 edges. And lastly, we're going to do faces. So the face is where the edges and vertices together meet and to create our face of our shape. So on a cube, we're going to do this in red. This is our face. This is another face. Can anyone tell me how many faces there are here in total?
5.
5, okay. So we have 1, 2, then we have our bottom face down there. Then we have our front face. We have our side face, our top face, and a back face here. 1, 2, 3, 4, 5, 6. In total, we have 6 faces. Okay, good job everyone. So now that we've learned all of our components of a cube, we're going to move on to something a little more. This is called a prism. You might also recognize it as a pyramid. So can anyone tell me where the vertices are on this pyramid?
4.
Okay, let's count together. 1, 2, 3, 4, 5. Because this bottom is like a square, and then we have 1 point at the top where they all meet. So we have 5 vertices. What about edges? Can anyone tell me how many edges there are?
9.
9. Okay, let's. So blue. 1, 2, 3, 4, 5, 6, 7, 8. 8 edges. Sorry, this marker's not the best. Okay, and lastly, faces. Does anyone know how many faces are here?
4.
4. We have our one big face. 1, 2, 3, 4, and here. Sorry, it's a little hard to see. And then our last one is on this side in between those 2 lines. So there's also 5 faces. Perfect. Now we all know how to find our vertices, edges, and faces of 3D shapes.
Good morning, everyone. So for the second lesson today, we are focusing more on grades 5 to 6, and I will be introducing Euler's formula when talking about 3D shapes and polyhedrons. So first we need to find all the components of the 3D shapes. So for the first shape, we have a hexagonal prism. And can anybody tell me how many vertices there are in this prism?
7.
Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a hexagonal prism has 12 vertices. And can anybody tell me how many edges does this shape have?
6.
10.
Okay, let's count it together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So our hexagonal prism has 18 edges. All right, and for the last one, can anyone tell me how many faces does this shape have?
9.
9. Okay, let's count it. So we know that there is the one face here at the front, as well as the face in the back. So we have 2. Then there are 1, 2, 3, 4, 5, 6 edges on this one face. So we know that we can add 6, and we will have 8 faces. Okay, so our hexagonal prism has 8 faces. Now, we want to take Euler's formula, which is vertice plus face minus the amount of edges that we have. And Euler's theory is that this is always going to equal 2. So now that we have our variables for our hexagonal prism, we're just going to substitute the value that we have for that letter. So the amount of vertices we have is 12. So we're going to write underneath 12 plus, can anyone tell me how many faces we have?
8.
8, perfect. So then we have 8 faces minus the amount of edges. Anyone?
18.
Perfect. So, equals 2. We then want to break this down kind of into some smaller pieces so that it makes it easier for us to find the answer to our solution. So we're going to break it down. We're going to take the 12 plus 8 first, and we're going to add that together. And so that equals 20. So we have 20 minus our 18, which still is going to equal 2. And so 20 minus 18 is 2. So 2 equals 2, meaning that we know that this shape is a polyhedron because it fits into Euler's formula. So for my second question, this is going to be directed more at kind of grade 6. We are going to be testing Euler's theory. So we are going to first find all the variables of a cylinder. So can anybody tell me how many vertices does a cylinder have? 2. Okay, so we're going to check that. As a recap, all of our vertices have to meet with 2 edges at a point. And there is no points here on the cylinder, meaning that we have 0 vertices in this shape. Okay, so now we have to check to see how many edges there are. So can anybody tell me how many edges are in a cylinder?
3.
3. Okay, see, 3 would be a great guess because there are 2 faces, but since this shape is rounded, there's actually no edges. Since an edge needs to connect at another point, it needs to have a vertex. And since we already know that we have 0 vertices, we can then assume that this shape will have 0 edges. Okay, now can anybody tell me how many faces does a cylinder have?
3.
3. That is correct. A cylinder has 3 faces because we see here at the top, this is the first face, this is the second face, and this is the third face. The third face is kind of like a square wrapped around these edges, but since it then becomes a circle, it has no edge. So we have 3 faces with our cylinder. And now the question is asking us to use these variables to check to see if the shape is a polyhedron using Euler's formula. So from our previous lesson, we know that Euler's formula is our vertices plus the amount of faces that we have minus the amount of edges that we have, and that answer is going to equal 2. So using our formula, we're going to substitute in all of these variables that we have found and collected, and see if our answer equals 2. So for vertices, we know we have 0 vertices plus 3 faces minus 0 edges. And that's going to equal 2. So let's check to see if this is correct. So we're going to break it down again into a smaller section where we're going to do 0 plus 3. And we all know 0 plus another number equals that number. So we have 3 minus 0 equals 2. Now we're going to solve for this, which again is another 0, meaning that our answer is 3. And since 3 minus 0 is 3, it does not equal the 2 that Euler said that this rule of thumb works for, which means that this shape, although it is considered to be a prism, it is not a polyhedron because it is without vertices and edges.
So using from what we know from grade 5 and 6, we are now going to solve the unknown variable by isolating the unknown variable to one side of the equation. We recognize that the unknown variable is f, but using the rules of bedmass and pedmass, we have to solve whatever is in between these brackets, 6 minus 2. Now, what is 6 minus 2, guys?
-6.
Correct. -6. However, also using those same rules of pedmass or bedmass, whoever taught it to you, it's the same thing. Whatever this value is, it changes the positive value. So now, the equation is now f minus 6 equals 2. So, now, the second step, we have to isolate this. Now, how do we do that? Well, it's actually very simple. We have to take away this number and put it on that side. Now, again, how would you do that? Again, it's very simple. All we have to do, I'll use a different marker so it's easier. We have to add 6 to this side. Also, because whatever we do on this side, we have to do it to the other. So 2 plus 6 as well. But now these numbers cancel out. So now all we're left with is f equals 2 plus 6. Now, what is 2 plus 6, guys?
8.
F equals 8. But now, we have to check if this is correct. Now, using Euler's formula, F plus V minus E equals 2. Now, in this equation, using the numbers, from this equation, we know that F is 8 plus V, which is 6, minus E, which is 12, equals 2. Now first, again, using the rules of bedmass, we are going to add 8 plus 6 first, which is 14. And then minus 12. Now what is 14 minus 12, guys?
2.
There we go. Now using this, we now know that Euler's formula proves these numbers add up.
Thank you guys so much for joining in on our lesson on Leonhard Euler and his works in geometry from all the way from grades 4 to 8. I hope you enjoy. Thank you.